When we want information from a database, we write a query. The syntax is select field list from table name. Here we are using the DB Basics database context, and we're requesting all records and all fields from the shopping list table. In our results set, we see 7 rows and 3 columns. The keyword select requests information to be displayed, and the asterisk sign is a shortcut for saying we want all field names. The keyword from chooses a specific table. We are able to run this query to retrieve the information either by clicking the red Execute button in the toolbar above or by pressing the F5 button on the keyboard. To start, make sure you've run your setup scripts and have opened a new query window. Now we want to run a query against the DB Basics database. One way to do that is to click this drop-down arrow and change it to DB Basics. Now, sometimes you'll notice that this drop-down arrow is disabled. That happens if you clicked on the left side of the screen. If you're clicked on the right side of the screen, it will be enabled just fine. Now we want to run a query where we're going to select all fields from the shopping list table. And we see we get 7 rows and 3 columns. We could say we have 7 records and 3 fields. Now, if we weren't in the DB Basics database and we were in the master database, this query would not work. So we need to switch context to the proper database before we can run a query. Now, oftentimes, your query window starts in the master database, and you don't want to have to manually select this drop-down. If that's the case, it's very common for the first statement to be a use statement, which switches you to the correct database context. I'll type use DB Basics and go. As I highlight this code and hit execute, look just to the left of the execute button and watch. It will flip the database context. Now it's DB Basics. Now querying from the shopping list table works, even if you start out in the wrong database context. Now, table names can optionally have square brackets around them. If we run this, it's not going to change the result. Although one query uses square brackets and the other one does not, they get the exact same result set because it's the same table. When coding, we rarely take the time to put square brackets around because it's more work. One of the times this is needed is when we can't tell where a table name starts and where it stops. For this example, let's expand databases. Let's look in DB Basics, and under Tables, let's find there's a shopping list table that we queried from, and there's also a shopping list table with a space in the name. Now to SQL Server, this looks like you're querying from the shopping table, and there's an extra list option on the end which it doesn't understand. Therefore, this query errors out. But if you have a table with a space in the name and you want to delimit it, so you know this is one object with a space in the middle, then you would be required to use the square brackets. Now we can get the information out of the shopping space list table. When coding, we rarely use square brackets because it requires extra typing. The only time it's helpful is when we can't tell if a table name starts or stops, or at least that's one of the ways. This shopping list table was not accessible by using its name without the square brackets. Using the square brackets made the data in this table accessible, and we were able to get the result set. Let's query from a different table of DB Basics. Let's query from the employee table. And let's get rid of our use statement at the top. So this is our only statement. And notice that Sarah Smith is our first employee, and the last one is Rick Moreland. We have a total of 16 employees. Now, without changing the code, this query is going to run differently because the DB Basics database has an employee table, but so does JProCo. Run this in the JProCo context, and notice we only have 14 employees. Alex Adams is the first employee, and Jenna Smith is the last employee. Employee is actually a great name for a table that holds all of your employees. A bad name for a table would be this: select all fields from. Don't name your table from. Select star from. Another bad name would be select star from select. Yeah, even if you're Campbell's Soup and you're trying to track your select soups, don't name your table select. Another not so good name would be if you were tracking charity grants and you called it grant. Notice with these last three queries, they all turn blue for the table name. The reason they turn blue is these are SQL keywords. Employee is not a keyword, so it made a wonderful name for a table. But here's a little secret. The grant table actually exists in JProCo, and we can't get data out of it. Let's take a look at JProCo tables, and notice the grant table sits right here. Well, if we want to specify that this is the grant object, in other words, the table, and not the grant keyword, we can put square brackets around it, and now we can get the data out. So you see a list of very bad names for tables because all of these names are keywords in SQL Server. But is that necessarily because somebody was just being silly or not very foresighted? Nah, maybe the database is very old, and you know the vocabulary of SQL Server has grown over the years. Each version of SQL Server adds new keywords. Who knows, maybe someday in the future, employee will wind up being a keyword. Grant has already been added as a keyword a long time ago, and we already have a grant table. So the way we got the records out of the grant table was to put square brackets around it. That's our way of telling SQL this is an object, not a keyword. Please query from the grant table. Do not try to use the grant keyword. Rather than deleting this code and starting over, let's just open a new query window. That way we can go back to this one anytime we want. This query window will be set to the DB Basics database context. And let's start off by looking at all the records again from the shopping list table. We want to find all of the items that are exactly $1.25. It's a small enough table where we can just look at ourselves and see that 2 of the 7 records are exactly $1.25. But what if there was 2 records to find out of 1,000,000? That might take a little more work from us. Let's let SQL Server do it. We will put criteria on this query by typing where price is equal to 1.25 and run it. And there's the 2 records we're looking for. Great. Let's go back to our first query window, the one that has the employee table. And let's look at all 14 employees. How many of these employees have the first name of David? Let's put where first name equals, now this is not a number, this is a string or a set of characters, so we're going to surround it in single quotes and type DAVID. And we run that, and we see we have 2 Davids. Okay, if we have 14 employees and 2 are named David, how many are not named David? That'll probably be 12. And to do not equal to, we just put an exclamation point in front of the equal sign, and we're finding everybody who is not named David. Well, let's go back to finding everybody who is named David. And we're looking for all the Davids or all the Lisas. So we'll type or first name equals Lisa. And it looks like we have 1 Lisa and 2 Davids. Now we could continue this. We can type or first name equals Eric. And we see we have a larger list now. What if we wanted to list exact matches without having to type or first name all over again for each match? In other words, we want it to look like this. We're going to list every exact match in its own set of quotes inside of parentheses. This won't work because the equal sign does not look for multiple exact matches. It only allows 1 exact match. But if we change this operator to in, it'll find Lisa or David or Eric. Since we rarely need to see all the records in a table, Often, we use the where clause to limit the result set to just the records we're interested in seeing. We simply don't want more records to sift through than is necessary, and we just want to see what really matters to us. Similarly, it's also possible to see too many fields in your result set. When this happens, we can limit the number of columns returned in our result set by affecting the select list. In the JProCode database, let's change to looking at our employee table. We're getting a few fields and quite a few records. We still want all 14 employees, but we only want the first name and last name fields. So let's put first name, comma last name right after the select. We get our 14 records, but only 2 fields. By listing first name and last name separated by a comma, we're just getting an explicit field select list, the ones we asked for. Doing star gets all the fields from that table. Optionally, we can say this first name field is from the employee table by doing employee.firstname and then employee.lastname. We get the same result. We're being more explicit. This requires extra typing, but is sometimes needed when we have 2 tables or more in a query, and 2 of those tables have a field with the exact same name, and you don't know which one you mean. For example, we might have a contractor table that has last name and an employee table that has last name, and we need to differentiate which one we're looking for. So here's the anatomy of a SQL query. Now above the query, we can use a use statement just to set the right database context. But let's look at the query itself. After the keyword select, you're choosing the fields or columns you want. After the from, you're choosing the table or tables you want. And the optional where clause is for criteria, to filter for just the records you're looking for. Time for Lab 3, Skill Check 1. Take a moment to pause this video and challenge yourself to do this skill check. Skill Check 2. Take a moment to pause this video and challenge yourself to do this skill check. Skill Check 3. Take a moment to pause this video and challenge yourself to do this skill check. Skill Check 4. Take a moment to pause this video and challenge yourself to do this skill check.